In this lesson, we are going to look at walks, trails and paths in a graph. So, consider a graph Z that I have shown here. It has these nodes A, B, C, D, E and F, and you have seen the edges in this graph. So, a walk starts at a node and it consists of edges or links and nodes and ends at a node. Some nodes and lines or links may be included more than once. So, you can visit a node more than once, you can use an edge more than once in a walk. So, the length of a walk is the number of edges that it has. So, for example, this particular walk that I have listed, B to D to E to B to F to D to B to A, is a walk with a length of 7. And then there is a special type of walk called a closed walk that begins and ends with the same node. So, B, D, E, F, D, B is an example of a closed walk. And finally, a cycle is a walk with at least 3 nodes which has distinct lines. So, B, D, E to B is a special case of a walk. A trail is the next concept that we have to learn. A trail is a special kind of walk which has distinct edges. So, an edge is not repeated in a trail, but some nodes may be included more than once. And the length of a trail is the number of edges. For example, in this particular graph, B to D to E to B to A is a trail that has 4 edges or has a length of 4. And note that the walk that I mentioned in the previous slide is not a trail because edge BD appears twice in that particular walk. Finally, we are going to look at this concept of paths. So, a path is a special kind of a walk with distinct edges and distinct nodes. So, essentially you cannot repeat a line and you cannot repeat a node in a path, and the length of a path is the number of edges. So, in this example, B, D, E, F is a path and that has 3 edges. So, its length is 3. Note that the trail that I mentioned earlier in the previous slide, B, D, E, B, A, is not a path because node B appears twice. There is this other concept of shortest paths in a graph, which you are actually going to see later on in some metrics. So, B, D, E, F is a path between B and F, and this has a length or distance of 3, and there may be many paths between a pair of nodes. For example, between B and F we have seen B, D, E, F. There is also B to D to F and directly the link from B to F. So, these 3 paths have respective distances of 3, 2 and 1, and we pick from these 3 the shortest one and name it a geodesic. So, geodesic is essentially a fancy way of saying the shortest path between 2 nodes. It is a path that has the minimum number of edges between a pair of nodes. So, in this particular example between B and F, the geodesic distance between B and F is equal to 1. Of all the various shortest of all the paths, this is the shortest paths between those 2 nodes. And these shortest paths or geodesics are very useful in some of the centrality metrics that we will see later on. Note that it is possible that sometimes there is more than one shortest path between a pair of nodes. That is likely. The other thing to note about geodesics is sometimes if a graph is not connected, like one of the examples that we saw earlier where a graph had 2 components, then the geodesic between at least one pair of nodes, one node in one component, let us say, and another node in the other component, that geodesic distance is infinite. Another concept that is related to paths is what is called as the diameter of a graph. So, consider again this particular graph y. So, this concept of a diameter has to do with the largest geodesic between any pair of nodes. So, in this example, I have nodes A, B, C, D, E, F, and I can go and find the geodesic distances or the shortest path distances between a node and any other node. So, I have distance between A and B is 1, A and C is 2, A and D is 3 hop path, that is 3, and so on. So, I go down the list, I list out all the geodesic distances, and then I find what is the value of the maximum geodesic. So, there are two cases, dA to D and dC to D, where the distance is 3, maximum the shortest path is 3. So, the maximum geodesic is equal to 3 in this case. So, the diameter of graph Y is equal to 3. So, we have studied walks, trails, paths and geodesics in this lesson. Before we go to the next lesson, let us take a look at this particular quiz. So, the true false question, the first one, geodesic is the shortest path between a pair of nodes. Answer is yes, it is true. The next question, a path starts at a node, consists of edges and nodes and ends at a node. Some nodes and lines may be included more than once. Answer, false. A path does not have any repeating nodes and lines.